Welcome to the first event of KataMeet. So this is the first event of a rather informal conversation between a member of Katalon and a user and a Katalon user. So uh, the reason we want to try to do this is because we want to have different perspectives on how our users are using the product to enable other users with information on how they can also use the product as well. So I am Thomas. I'm a software engineer at Katalon. I worked on Studio for quite a long time, and I also developed some of the features that you may be familiar with, such as smart weight, self-healing. And so today it is my pleasure that I get to speak with Jagmit. So Jagmit has more than 10 years of IT experience across different development and testing roles in different industries, such as healthcare, media, logistics, and finance. He has extensive experience designing test automation frameworks for web and mobile applications using various tools and languages, as well as experience in implementing different CI/CD pipelines. When he is not working on automation, Jagmit enjoys playing racket sports, hiking, and skiing. Hello, Jagmit, and welcome to the show.
Thanks, Thomas. Thanks for introducing me.
Okay, so before Chamit does the heavy lifting, I would like to speak a few words on our topic today. So our topic today is Flaky Test, and specifically, we want to talk about Flaky Test in mobile automated testing, including some of the problems and also the solutions and best practices. So this is the agenda for our webinar today. It is an outline, what we're going to talk about. So I'm going to talk just a little bit about Flaky Test and its potential drawbacks, and also on some of the reasons that Flaky Test occurs in automation testing and specifically in mobile automation testing. And then Jagmit will uh, introduce some of the solutions and also best practices that he and his team have applied over the years. So let's get started. So before we jump into the solutions, let's talk about the problem first. So what is Flaky test? So a Flaky test can be defined as a test that exhibits different behaviors every time that it is executed. And there is no code change either to the application or to the test cases. So it's like when you're a flaky friend and you say you will go to a party, but then you don't show up, then you're a flaky friend. And that's the same thing with flaky test. You exhibit different behaviors than what you are expected to do in a sense. So that's what flaky tests are, and why flaky tests are such an important problem in automated testing. And that's because it has several drawbacks. So let's talk about the drawbacks. First of all, flaky tests are costly. What do I mean by this? So the first type of cost that is kind of obvious is the cost of time. So whenever you have a flaky test, you will have to execute that test again at least. Or if your CI/CD pipeline is not developed, you have to execute the entire pipeline again. So that will incur the cost of time, which is which can be very expensive, especially when you have a release drawing near. So that's the first type of cost, and it's rather obvious. And the second type of cost, which is a little bit more elusive, is the decrease in confidence in your team. So I think that when you have a CI/CD pipeline with a bunch of tests, and when the pipeline fails, your first instinct is to just execute the pipeline again, or to just get somebody to fix, to see what is the problem. I think that's a sign where your team have a very low level of confidence in automated tests because automated tests are supposed to reveal the problems of your applications. So ideally, if the CI/CD pipeline fails, it means that your application has some defects, and you just need to see what is it, and then you can just fix it. But in a scenario when automated tests are flaky, what you end up with is a failed CI/CD pipeline can mean many things. It can mean that the tests are flaky. It can also mean the application is has some defects. You have to spend time and efforts to investigate which is the actual case. So when the when this type of cost exceeds what is acceptable, your organization is gonna regress back to manual testing because, well, the justification for automated testing is the saving of time and efforts in its application. But if automated tests are the cause of such waste of time and efforts, then it makes more sense to just have manual testers to go over the applications. And that's not just one time. Your organization is going to grow wary, gonna grow is gonna become afraid of automated testing in its future projects as well, and it's gonna seriously damage the extent to which you can evangelize automated testing in your organization. So that's um, the problems with flaky test. It decreases confidence and it costs a lot of time and efforts. So this is what I just talked about. This is like the lack of confidence as a result of flaky test, and really the comic is, well, it's quite comical first of all, but it also contains a bit of truth in it. So when you become desensitized to flaky test, it becomes kind of a quite a problem for you as a tester and for software developers on your team as well, because, well, you have to maintain a bunch of CI/CD pipelines that fail all the time, and it's going to seriously impact the morale of the team. So let's talk about some of the reasons flakiness exists in mobile test automation. Some of these reasons are also applicable on the automated testing, test automation level in general, not just specifically mobile test automation. So we have the first reason being tests at the UI layer are very fragile in nature. And this is because, well, UI constantly change, especially when, you know, in the modern world, when an application has to undergo constant changes in user interface in order to continuously improve the user experience, you have tests that can get very flaky, especially on the UI level. And you also have unstable API and environment issues where an API is only in development stage. So a lot of changes can be made to that API, and even at the API level, some of the tests may also be flaky because, well, due to the constant changes introduced by the development efforts. And a third reason is incorrect element locator strategy. So this is a technical problem in a sense, because choosing the correct locator strategy has always been the most important part of automated testing, especially in the UI level and less so on the API level. And incorrect element locator strategies can cause, false positives, which can produce errors in a log that are irrelevant to the problem at hand. And so it's going to cost a lot of time and efforts, even more so than regular flaky test. We also have test data and application data dependencies. Sometimes, especially with microservices, when you want to test one microservice and it depends on other services, if the dependent services are not started up correctly, then you cannot test the service appropriately, because well then the tests are gonna fail. But that failure is not because of the service having some defects, but it's because the dependencies are not loaded properly. And the final problem is a little bit also quite technical as well, especially if you want to simulate environments in which internet connection is not stable. If you want your application to work well even under these conditions, then you will have to handle network issues and glitches as well. But these setup can seriously affect the way that you design your test, because well, timing issues are one of the most uh, like serious problems, especially when you use Selenium uh, for automated testing, because you have to handle a bunch of waiting conditions, for example, in order for your test to pass. And like that's kind of a network problem related thing that flakiness that cause flakiness. So these are the reasons for flakiness in mobile test automation. So that's kind of an introduction on the topic of flakiness. And now to the part where we present the solutions and the best practices. I'm gonna hand things over to Jagmit to go over some of his experience, as well as some of the best practices in the industry. So Jagmit, can you take over?
Yeah, I'll start sharing my screen. Just a second. Yeah, so I hope you can see my screen. Hello, everybody. Thanks, Thomas, for introducing me and introducing more about those initial slides, which is very useful information. And thanks to all the attendees. I have seen people joining from all over the world. So hope you're going to enjoy and our the solutions and what practices we have experienced myself working in the industry for quite a number of years. So the some of my own hands-on experience how we can reduce the flakiness and some of the solutions or best practices to adopt. You cannot basically have zero flakiness, but you can basically reduce the flakiness percentage. That's also a significant thing if you adopt some of the best practice and solutions. So, so what like so that there's some like what you call it a process. How do we can deal with a flaky test? So first is that we want to identify which are the flaky tests in your test suite, and then investigate the reason why there's a flakiness happening. So once, for example, you investigate the reason, then accordingly you can open a ticket or provide that information to the developer. Okay, this is my result of investigation, and this is causing the flakiness, for example. And lastly, then you want to adopt those certain best practices that flakiness behavior does not happen again and again. Also, you want to basically take those steps to overcome those flakiness in your test suite's execution. So that's like repetitive, three-step process to do with the to deal with the flakiness in the test cases or test suite in the regression suite. So to highlighting in detail the step 1 and 2. So to identify the flakiness in the flaky tests in your regression suite. So what you want to what you can also observe it, but there are tools which do this sort of a pattern recognition for you. So they look for the pattern of test results of a test case for a historic pattern, you can say. They look at a pattern for a number of execution runs. And based upon those pattern, they basically identify the flaky test in the regression suite. So you can have a situation that, for example, every alternate run, this test case is one time passing and other time failing, or it happens regularly. That's basically adds to a flakiness percentage. I'm going to talk about what's flakiness percentage, but that's like that indicates a very flaky test. But if you have situations that a test is always passing and then it fails, then it's a different behavior, because it is failing. It could be indicating a real like a real bug, not flakiness. So basically, that's the step. Like they look at the pattern of execution um, um, in the previous run. So more historic information you have, that helps you in giving more accurate information for the flakiness. And once you identify the flaky test, and then you want to investigate the reason of the flakiness. So the first step is that you want one is that you'll analyze the logs of that execution log of this flakiness of a flaky test. And in the execution log, it will, for example, shows you like a error message, exception message. For example, it's trying to communicate to an API or a DB or something, and that's giving you exception message. So from there, you can identify the root cause, right? So what is happening, which is causing a test case to fail? And then you can deep down further. For example, you can look at the other matrix, for example, CPU utilization or memory utilization. And then also you can look at the network activity logs. For example, there are certain profiling tools that provide this all this network activity log information in historic mode also. So these basically helps you identify the reason of the flakiness. And so this can be done manually also, but manual is manual. It takes a lot of time to basically do the investigation, identification, and investigation further. But then there are other but there are tools. For example, in a Katalon TestOps, there's a flakiness report, which provides you the flakiness percentage of a different test cases which are executing. So just to maybe introduce you about the Katalon TestOps. Katalon TestOps is a DevOps tool which have other features like reporting and other features built into a one common platform. So it have different analytics features and reporting feature. And flakiness report, what it is one of the feature which basically indicates the flakiness percentage of a different test cases runs. So and that's like a sort of like an intelligence built into this platform, which gives you the flakiness percentage. And so iterating it again, basically, so this Katalon test ops basically provides you the flakiness percentage. It do a more like a thorough analysis and provide the flakiness percentage. And more going in the technical definition of flakiness percentage. Flakiness is percentage is a change of the results. It could be a pass or the fail versus total number execution with the same configuration. When I same configuration, I means more like environmental. It should be exactly the same configuration. For example, a test case executing on for example, a Chrome browser. That's the same configuration. But if you have a situation that one test case executing a certain time on a Chrome browser and next time executing an IE, now there's a difference in the platform or the configuration. So that's not basically corresponds to the flakiness percentage. So in this test of basically what they also look is that the configuration of the test execution remains the same. That's one of the key criteria in calculating the flakiness percentage. And what we have seen is that higher the flakiness percentage, the more that indicates like unstable test cases. So there's a direct relation between the flakiness percentage and instability in the test case result and in the instability in the test cases. So this is one of the screenshot of a flakiness percentage. So here you can see different test cases on the left hand side, and the flakiness percentage is showing on the right hand side. And if you look at this in the middle, it shows you the pattern test execution pattern. So based upon the pattern of execution is going to calculate the flakiness percentage. So the standard model is that um, if a test case is, for example, always passing and then it fails in between, that's not basically, you can say, so not a flakiness, it could be an actual bug. But if the test case is passing one after another, one time it's passing, another is failing, that's basically a flakiness and indicates more flakiness. So basically it gives you the flakiness percentage for each test case it's executing in the test suite. So once we have identified, there's some one we have identified that certain test cases are flaky in nature, based upon the flakiness percentage it shows up. So you can accordingly, there's integration in TestOps with Jira. So you can accordingly put this information in Jira to indicate that, okay, this is a flaky test cases. We have to investigate the reason of flakiness and accordingly do a more like deep down into it. So you can provide that information to a developer who's going to look at this test case. It could be a developer or automation engineer who going to look into the on to the deep down into it, and basically figure out the reason of flakiness and basically remove those flakiness reasons and make it a test case more executing more reliably. So you can provide this information on Jira with this integration in place. Um, so based working in this industry as an automation engineer for quite a number of years, so this is my even my own personal on my personal experience, and also even in a testing community, um, they have the similar thought process, is that to overcome the flakiness, first you want to focus more on the API slash unit test versus UI test. So by the nature, API unit tests are less flaky versus a UI test. So try to focus more on developing this API unit test versus the UI test. You still need a UI end-to-end test, but the percentage should be less compared to the API. So I'm going to show you about this test pyramid model you want to basically adopt in your test automation projects, and then also focus more on investing if test automation in developing a test automation framework. For example, Katalon is one of the framework which is already being it's like a framework already being developed, and it's used by different people, different in a testing community. Um, if you have already a framework, there's always room for improvement to enhance it further. All right. So make your test execution like a framework as much advanced as possible, because more you put energy in advancing the framework, you're going to see the best results in reducing the flakiness and in the reporting and everything, right? And lastly, that's another key in reducing the flakiness, is to adopt effective element locator strategy. So like for example, I'm going to talk in depth about in the later slides, like for example, not to use XPaths and use more like a native element locator strategy versus XPaths. So talking about the test automation pyramid, so what we have seen is that more up you go the pyramid, for example, if you have the higher the flakiness percentage, right? And below, if the more below you go, below I mean if you at unit test level or API automation level, less the flakiness, right? So the focus should be, as a automation developer, is to have more and more API test or unit test. I know unit test is not exactly basically falls under the uh, um, automation developer responsibility. That's more like a developer responsibility, but it's always good to basically work with the developers, be an advocate to push for more unit tests, right? And in certain situation, you can also work with developers to maybe help them writing unit tests, or campaign for that, be a evangelist to basically push for more unit test. And that's basically, with this approach, basically it helps you overall reduce the flakiness in your test execution runs or in a testing effort in general. So this is a number from the industry standards, but also from my experience itself, like the 70 or 80% effort should be, or total number of test cases should be focused on developing unit test. 10 to 15 should be like API test, and maybe top layer, you still need an API end-to-end or UI test, and they should be like a 5% basically. End to ends basically should cover the functionality application as a whole, a few scenarios here and there, because you still need want to see that all the components of an application work together, but not too many, right? Because there are drawbacks of that if you focus too much attention on developing end to ends, right? And try to focus more business scenarios at the API unit level, right?
Yes, that's very interesting, Jagmit. So I'm wondering if, because according to my experience, uh, n- normally people have like a lot of end-to-end tests, like the anti-pattern that this slide is describing. So in your experience, why is that the case?
That's a very nice question, Thomas. So why is the case? It's basically what I have seen in a lot of teams. They say they have a perception that testing is a QA responsibility, right? And what's happening is at the developer level, as I said, like unit tests are basically more developed by developers. And what they do is they don't want to write, or they write it, or they develop it, develop it very at a basic, not many thorough coverage. So what their focus is to develop more features, and they push the code to testers to basically test it, right? So but the right model is that testing is a team responsibility, not you can't say that it's the developer responsibility or a QA responsibility, the team responsibility. And that's what that anti-pattern leads to, because it's a mindset approach. That's what it leads to, right? And also my experience is that in the management focus is that why not develop end to ends, right? At the end to ends basically also help you finding the bugs in integration layer or the layer underneath, right? In one of my previous organizations, we were asked to basically develop the field validation test at the end to end layer, which is such a bad practice. You can have it, but they're not going to work, right? They maybe work initially, but any changes in the layers basically going to screw it up. And basically, as you see in the comic diagram before, that's what happens. All the test cases are failing, all right? So yeah, so um, yeah, that's what basically happening in a lot of organization. They have a top in a reverse in pyramid approach. They do a lot of tests at the end to end, very small, relatively small at the API layer, and the very bare minimum unit test level, which is such a bad practice.
Yes, yes. I think the idea that the phenomenon where organizations usually have a lot of end-to-end tests is dictated by management is a very good idea, because end-to-end tests are very understandable to business people, while lower level tests such as API and unit tests are not very business friendly.
Yeah, that's another good point. Yeah, because they're more understandable at the business layer, because they see it happening, for example, execution happening and all this stuff. Yeah, that's another good point.
Yeah, and I would like to add another point to this is that I think that regardless of the pattern of, even if your organization adopts an anti-pattern, it's eventually gonna transition into the pattern whether you want it or not. So in my experience, there has been a company where I see they have about 1,000 to 2,000 end-to-end tests, and then when they reach uh, 2,500 or something, they are faced with a tremendous increase in the execution time because the tests are so flaky that it takes them several days or even weeks to execute the entire end-to-end test pipeline. So what they did is that they eventually, so first of all, they stopped the development of the end-to-end test and they start focusing on developing API tests, which is the second layer here. So I think the natural evolution of an organization that adopts this anti-pattern, if your organization is adopting this anti-pattern, is that you need to basically enlarge the middle layer. You need to increase the amount of API tests you have first, and then you need to stop developing the end-to-end test. And then finally, when your API test becomes stable, you can focus on developing more unit tests. So in my experience, that's how things went down.
Yeah, that's true. Actually, we are doing the same thing. We are focusing more on API tests to cover different business scenarios. So we always think, okay, this scenario can be developed at the API layer, and if yes, we'll write an API test for that. Yeah, thanks, Thomas. Let me go to the next slide. And also, talking about the automation framework to reduce the flakiness. So automation framework has a key component is that you want to reduce the code reuse, for example, by implementing generic functions. For example, Katalon itself has a whole big library of generic functions which you can reuse in your code. So it helps you basically achieving maintainability in your test cases. And another good pattern we want to adopt, which is a part of the key concept in the automation framework, is to basically adopt a page object model. So and then um, and then and also is a object having an object repository of different elements which your scripts are going to use. So the benefit of having the repository is that all the elements which your test suite collection require is sitting in one place. So for example, element ID changes when when, for example, the change in the application. So you make a element ID update at one point and it get reflected all over in different scripts which are referring to that element ID. So you basically make a change and it get reflected all over. So that's basically and that's whatever you do at the framework level, how much you make it more robust and modular, it helps in reducing the flakiness. And lastly, some of the tools, for example, Katalons or other frameworks, comes with a inbuilt element locator, basically tools. So these locator tools are optimized to basically provide you the best locator strategy. So I'm going to show you in the next slide what I exactly mean by the locator strategy and the tools which supports it. Um, so talking about the location strategy, one key thing you want to avoid is to not use an XPath. So and when I say XPath, specifically in absolute XPath. So as you can see that in the slide, the last point, the path is saying is an absolute XPath. So you want to avoid that. I would say in all the situations, because what happens that any changes to an app, right, can easily break that XPath. So when the XPath break is going to cause your test case to fail, right? And also the XPaths in general are slow. When I slow, it basically um, they're slow in basically helps in they're slow in a sense that they cause the test case to execute slowly because um, they takes their longer time to basically find the element using XPath. So that causes the execution cycle to be slow overall. So instead of using like XPaths or specifically in absolute XPath, use more like a native strategy versus XPath. the benefit of using the native strategy, for example, it could be accessibility ID, name, or um, or or for example, in the Android world, you have a UI automation IDs also. So any of those native strategies are basically less prone to the app hierarchy change, and plus they are faster. Basically, they helps in executing the test case faster. So here's a screenshot of one of the Katalon object repository. So here you can see that it gives you an option to use XPath also, but the correct way is that you use an ID, like a definite unique ID versus XPath. So it allows you to choose a different locator strategy um, based upon what you think is more robust for your test cases or test scripts. Yeah, but here, for example, they're using a name and an ID to basically identify an element. So in the next slide, I'm going to show you a demo. It's a recording. I'm going to show you the talking about the element locator strategy, and also about the flakiness percentage in the Katalon TestOps. So it's a video recording. So I'm going to play back the video recording and also talk on that. So this is one of our test case execution. So in the Katalon test ops, you have this report and analytics engine built into this reporting framework, and um, and then for a test use, for example, we are executing it for quite a number of times. So it basically displays the flakiness percentage for each test case. So it, as I said before, it looks at the pattern of a test case, and based upon the pattern of execution of a test result pattern, it basically calculates the flakiness percentage. Um, yeah, so as I said, like if a test case is always passing and then failing in after like a few execution, that's not a flakiness. It could be a real bug. You want to look from that angle. But the more the historic information you have about a test case, more accurately it calculates the flakiness percentage. Um, Yeah, so after you see the flakiness percentage, you can accordingly open a Jira ticket. So in the Katalon Test Hubs, it has an integration with Jira. So you can so once you have when you have seen the flakiness percentage of a test case, you can provide that information, or you can do a more like a investigation of a flakiness percentage, and then accordingly address that issue in a Jira ticket, or you can assign to developers or an automation person to look at this from the flakiness point of view. Yeah, so yeah, so here you can open this integration with Jira and provide this. For example, this is one of the test case execution logs. You can provide this log also in the Jira ticket. And this is Spy mobile, yeah, Spy to help you this mobile spy to identify an elements for an Android application. So here I'm loading an application. So first of all, first I choose an APK file, um, and then I load this APK file on a device. It could be an emulator or a real device, and it provides all the element ID for that screen, the screen in focus. So that's a screen in focus. It's basically a reflection of an application on the emulator. It's captured the screenshot of that, and now it's providing the element ID for each element. So here you can see it has identified an object with the properties. So it has chosen a native strategy, which is Android UI automated strategy by default. So in the location strategy, you can see, but you have an option. For example, if you think that other strategies are better, You can choose other strategy, for example, an ID or a name, and accordingly is going to generate an element. So yeah, so let me yeah, so here it gives you a different strategy you can adopt. For example, if you generate an XPath, you generate an XPath. But as I said, XPath is not absolutely, especially XPath is not the way to go as an elemental location strategy. Is a good, not a good practice. For example, name and ID, which is unique, is the best one because even an app hierarchy change, they're not going to cause your test case to break. And similarly, for an iOS, you can have iOS specific element locator strategy, which is, I think, so when, for example, iOS predicate string or a chain. Yeah, so you can choose based upon your target application. So here, what I'm doing is that I'm selecting those elements which should be part of the object repository. So all I do is I save that and make those elements as a part of the repository. And what you were seeing in the screen before here is another layout. So yeah, you identify here, you can make a checkbox which strategy you want to adopt locating an element. So you can use the judgment call to basically use the strategy which is more robust, not fragile enough. So yeah, so it gives you options basically. So for example, here this is a XPath we're choosing, which this is more for demo purpose. I'm choosing XPath, but I would never use XPaths. Yeah. So
Yeah, that's very interesting, Jamit. And one thing I'd like to add is that the advantage of having a tool that automatically generates the locators for you is very powerful, especially when it comes to iOS. So so in my experience, someone on the forum told me that once he switched from using an XBAT locator to an iOS class chain, uh, he witnessed a tenfold increase in the execution speed. So the advantage of so it's we are able to take advantage of the built-in iOS specific locators, which is very powerful in my opinion.
yeah, that's true actually. Yeah, even I have experienced that for on the Android space also.
Yes. Okay. Thank you, Jamit. Thank you for your demo. It's very helpful. And so before we go to the Q&A session, I would like to open a poll to gather feedbacks from all of you. So please take a few minutes to finish the poll. And then in the meantime, if you have any question, you can ask it in the Q&A functionality of Zoom, or you can just type in the chat box and me and Chapman will try to answer it. So also there have been interesting questions in the chat. So I would like to kind of go over an interesting question. Is that someone asked me that it seems like decreasing the number of UI tests is not a good practice, and I would agree. So what I mean is that you should decrease the percentage of UI tests with respect to your overall regression suite. So if previously you have 500 tests that take up to 75% of your test suite, you should develop more tests at the lower levels so that the percentage of the UI tests decrease. So that's a very interesting problem as well to consider.
Yeah, and also I want to add that for example, you have an UI test to cover certain scenario. So you want to decide that, okay, can I automate those scenario through an API test? If yes, then have an API test versus a UI test, and have more coverage of as many scenarios you can have through an API test. And those UI tests should be like end to ends. So have few end to ends, basically cover an application as a whole.
Yes, someone, John asked that, does the web recorder allow changing between identifiers and XBAT? So yes, you can change between XBATs and attributes and CSS and also image-based locators uh, using the web recorder. So just go to the project settings and choose whichever method you want to be set to the default method of locating elements. So Jeff asked, when will this KataMeet recording be available? It's usually 1 or 2 days, but I think we're gonna send you the video to your email if you already registered for the webinar. And Harold asked if the information are equally applicable to laptop. I assume he means web testing. So yes, I think most of the problems and solutions that I and Jagmit described are equally applicable to web testing as well, especially considering the best practices of following the test pyramids. I think you should follow that regardless of mobile application testing or web testing.
Yeah, only difference is the location strategy. For example, in iOS and Android, they have a specific strategy for their for the application, which is could be different for web application.
So Adam asked, how do you balance trying to have fewer end-to-end tests while not making those tests longer and having possibly many breaking points in the test? So what I would say is that you should only pick a few key uh, user flow that you want to run end-to-end tests with. So normally, so I don't think that if you want to try to test user experience, which is what end-to-end tests are for, you can have more than 1,000 test cases. I mean, that seemed a little bit too much for me. So I think you can safely reduce the number of end-to-end tests and not having them uh, increased in terms of their length. And I think the key to that is to consider what is really important that you have to use end-to-end tests for.
Yeah, in general, end to end should not be very long because it's difficult to maintain and have an effective test result. It should not be, for example, like a 15 minutes long or 20 minutes long. The ideally it should be like 2 3 minutes long. That's also a max.
Okay. Someone asked how much is too flaky. So this I mean this really depends on how much risk your organization is willing to take. So for example, if you run a mission critical software, then you wouldn't want uh, a very high degree of flakiness. But for example, if your software is not mission critical in the sense that it's like the in the sense that you cannot have it fail in any case, you can withstand a certain amount of flakiness. So I think about 90%. If your test is 10% flaky, which means it passes 90% of the times, then I think it is an acceptable number. Of course, you have other sources. For example, Google famously said that a 98% uh, a test that is robust 98% of the time is too flaky for them. And this is understandable because they have like thousand, 100,000 of tests. So obviously when you multiply the flakiness together, it becomes a very serious problem. But I think most organizations can withstand a lower degree of flakiness.
Yeah. So the other question: if you have 40 screens on application where there's approximately 100 fields on each page, what kind of which are kind of mandatory for your application? How can you make end-to-end for 2 to 3 minutes? So if you have such a scenario, so make your test for each screen. All right. So basically have not like a test which runs all across a different screen. I know in certain situations you have to have a test basically or encompasses all the different screens, but see if you can break your test cases and have for each individual screens. All right. Um, See, look, there's no bulletproof answer for that, I know, but try to break your test case in smaller chunks and instead of having a lengthy test cases. And if possible, try to reduce the dependency from one test to another test. Um, so this,
Yes, yeah, yeah.
sorry.
Someone also asked that if an application does not use APIs, so how do we use API tests? So I think I would take a similar approach to Jamit's previous answer, is that you need to encapsulate your UI test into a page object model essentially. So what I mean is that you should try to group your UI test to just test on the page level. And by approaching by that approach, I think it will decrease the flakiness tremendously because you can easily see what logic you have to test on a page.
Yeah.
So how do you address flakiness caused by web click events not firing consistently? So this is a very interesting problem. So there are many ways you can handle this. First is to repeatedly try to fire the click events and then try to catch the click event that actually works. And also, Katalon provides you with a retry strategy that will enable you to kind of retry a failed test case immediately. So I think that's another way you can approach dealing with flakiness, because retrying a test immediately and wait for it to pass before proceeding with other tests can save you a lot of time.
And I also add to it in certain situations you want to, for example, use a JavaScript executor, right? If you have a flakiness behavior in those scenarios, for example, use JavaScript executor. In general, I have seen that it makes your test more reliable firing those events.
Yes, and final question, is it possible to import Python Selenium test into Katalon? So unfortunately, the scripting language of Katalon is Java and Groovy. So right now you cannot import Selenium test written in Python into Katalon.
That's another question I want to see.
Okay, so Aaron also asked that on average, each test case runs 40 to 50 seconds, and a test suite collection takes about 20 minutes to execute. So should he consider doing these API-based tests, or just trying to reduce the time a test case takes?
Yeah. So as I said, like in general, 40 like in general your test suite end to end should be like maybe like ideally with 10 minutes, but see if you can have the similar scenario for a UI covered at the API layer. See if you can do that, right? And if yes, try to develop an API test versus versus a UI test. For sure you need some API like UI test end to ends. And my focus is to reduce as much UI tests as you can. No, the end to end should be more focused as from the like what you call an acceptance test, which a user of an application wants to interact with an application, right? Those are end-to-end, like a user acceptance test. So make those as a GUI test, right? And rest different scenarios covered through an API.
Yep, I think that's a very good answer. Okay, so I think we are running out of time. So I want to thank you everyone for spending your time with us today. And if you have any suggestion, feel free to post your suggestion on the forum and reach out to our team at Katalon.business. And would be very glad to answer your inquiries. And also, if you have other ideas or stories you want to share with us, consider reaching out to us to be the next speaker on the next KataMeet event. So thank you, everyone. Again, I think it's been a great session. Thank you, Jamit, for your time.
Yeah, thanks,
And
Thomas.
yes, thank you. And have a good day, everyone. I hope you are all okay. And I hope you have a great day.
Yeah, thanks again for all the attendees. I know they are all sitting all over the world. Hope they enjoyed this session and hope to meet them again in the next KataMeet.
Yes, I
Thanks,
would hope
Thomas.
so. Thank you, Jamit. Okay, stay safe, everyone. Goodbye.
Okay, thanks. Stay safe.